Okay. We have in front of us this electrical system simulation that we propose. Simple one loop system in here. We are going to do the simulation using the block diagram method, which means from this sketch of each loop, or in this case of this one loop, we need to apply Kirchhoff's law. So I'm going to say sketch each loop, and then of course I'm going to put it maybe in here, and I say number 2. I would say, let's see, because I want it like this. Number 2 is going to be apply Kirchhoff's law. What does applying Kirchhoff's law mean? It says that the summation of the voltages in a loop should be 0, is what the law says on each loop. So in this particular case, this amounts to say that the voltage is, let's call it voltage of the resistor. Voltage of the resistor minus the voltage of the capacitor minus the voltage of the inductor. This should be equal to B. Or I could put here minus, and then this should be 0, right? Would you like to see it maybe that way, or this is okay? This is just fine, I think. We could say B sub R plus B sub C plus B sub I minus B equals 0, or written the equation this way. It doesn't really matter. So in here we're going to say this is the voltage of the resistor is going to be the current times R. This one is going to be 1 over C times the integral of I dt, plus this is going to be I times di dt equals to the voltage source. Okay? So this is the voltage across the resistor, voltage across this capacitor, voltage across this inductor. But you see the differential equation that we have in here, it's sort of funny because some terms have integrals, others have derivatives. That is not helpful for our purposes because we want to solve the differential equation. So one way of doing it is to be consistent. We could put it in terms of the chart. If I is equal to dq dt, so it follows that you could write the equation dq dt times r plus 1 over c. The integral of dq dt is going to be q, and then plus this would be I. If I is dq dt, this becomes d squared q dt squared equals to v. Yeah? And now we do have a second order differential equation. We have a second order differential equation, and in this case in terms of q. So once we have the differential equation, I would go and perhaps put the 3-step, let's see, let's move over here, and just put maybe step number 3 here. I would say convert the differential equations. Why don't we do it the second order differential equations? Equation into a block diagram. So in here we are going to say we can rewrite the differential equation here. What is this? All right. We could rewrite the equations in terms of the highest derivative. And to do that, we have this, we could write it like, see, we can move these terms to the other side or move this to the other side. So you could write that v minus r times dq dt minus 1 over c times q is equal to I times t squared q dt squared. And having done that, makes it easy for us to do the Simulink representation, I mean the block diagram, because now I can actually say, okay, look, this is the summation point, and in here I am going to have the first contribution to the sum is going to be this block B, similar to what we did with the mechanical system. But in here we're going to say there is two terms in here. One is this term that is minus 1 over c times q. The other term here is minus r times dq dt. And the result of this, as you see, is I times d squared q dt squared. Pretty similar to what we did the prior one in the method, not in the units, nor in the way the parameters are written in there. But the point is that this sum in here is represented in this picture, and this is the result of the sum. So the sum are all these terms that are coming into the summation point, and this is what goes out of it. So I think it's pretty clear we can relate this equation to this picture. Once you have it in this way, then of course it makes it a lot easier to process this and say, okay, look, this is d squared q dt squared, and if I integrate it once, like 1 over s, I am going to get dq dt, and if I integrate it another time, like 1 over s, this is going to be q, and then of course I just put a little scope in here like this, yeah. So in here you see the q dt multiplied by r, it jumps out at you because you have that in here, and you say, oh, it looks really good if I put this r in here, and I can complete the diagram here, see? No problem. And this one is multiplied by q, so if I do the same thing and I multiply by 1 over c, this is what I get. See? And I have completed my block diagram for the electrical system. Just like we did with the mechanical system, we can proceed now to draw it in Simulink. Perhaps one idea is to make it a little smaller here so it fits in this window right there. I think this is good because we can actually see it really well. And say, okay, bring MATLAB and Simulink, which we do have it in the in here we have the MATLAB window, and this is the Simulink block diagram in here. We had opened MATLAB and called Simulink. We have now the ability to begin drawing this. So what I would like to do is to click over here and produce a new working window that we need. Maybe if we can just share the spacing here, we'll do fine in producing this new picture. And here you go and bring this one, and on this we need one of these. Actually we need 3 of these guys, and you also need, from here we have other things that we don't have. Of course this one here, and then we also have the scope over here, and we need the blocks to do the integration. See? So you have them like that. And then in this summation point we want to make it bigger, and we need to read how the equations are written. See, it has the 1 plus and 2 minuses. B is plus and the others are minus, as you can see in the equation here. So if that's true, then we have plus and 2 minus in here, and we need to call this right here is our voltage V, yeah, and then this is going to be joined here, just like we did before with clicking the control, and then the next block it was joined. This we call it 1 over, what did we say was the letter I, capital I, right? And then here we know that we have the this control I for changing the direction of that block. Same thing over here. You see here the first one is the QDT, so that means that you connect from here to here, but making sure that this is R, right? Capital R, like that. And then if you see, the other one is 1 over C, 1 divided by C. Okay, this is going to join over here, and this one over here. See, isn't that cool how you can actually draw it really nice, and the software adjusts really nicely. So, and you have the block diagram that we had in here on the left hand side. We did it by hand. Now it's a nice picture in Simulink. Now of course nothing will happen, I'm going to put this block in here unless we initialize the values in MATLAB. And in MATLAB you have to say R, for example, is equal to 2, what do we have? The voltage equals to 1 maybe, 1 volt. Then you have that the C is equal to 0.02, and then you have that we did V with I is equal to 1, yeah. Hopefully I'm not forgetting any other ones that we need, but we could actually run the simulation here and see what happens. And sure enough, we got one error in here, but this is good because you see it's showing us that we forgot the C. So we forgot the C, and maybe what happened is I didn't put C. C is supposed to be capital. I remember.
You need a point. You got a comma in there.
Oh,
Period.
that is probably the problem. I didn't realize that, and so in here now that we should be able to see the simulation and see, you see it flat like this, but you really need to see it like this. You put this, expands and adjust this to the scale on the window, and of course produces a nice result for our electrical system, in this case the charge. If you want to do the let's say you want the current as the output, all you would have to do is to add another one of these to the block diagram and pick the signal from here like this, and then do a double clicking here, and then if we run the simulation again, you will obtain this would be for the current, see? So one would be the charge, and the other one is here for the current. Okay? Charge and then current over here. And that's the way we do the simulation for our simple electrical system, using the block diagram method, which implies writing the equations. It also implies creating a block diagram, and then of course doing a simulation in that Simulink actually starts, but the engine that runs this is MATLAB.